Hey guys, welcome. Yeah, so example 0 here, and as with all example zeros, big picture, which is, in this case, what is matrix multiplication? How do we multiply two matrices? So in this video, I'll answer both of those questions and hopefully more. Um, and if we fully succeed, then you will not only learn efficiently how to multiply two matrices, but you'll also learn it in a way that will stay with you. So to start, look at this. So if you want to multiply a matrix A by a matrix B to get a resulting matrix C, then if A is an n by m matrix, then B has to start with an m. So B can be an m by anything, where here I've called anything K. But what's important is that B starts with an m if A ends with an m. That's to say, the number of columns in A has to be the same as the number of rows in B. And of course, n and k also play an important role, and n determines the number of rows in C, and k determines the number of columns in C. Yeah? Note that this very important rule that we have to abide by means that matrix multiplication is not commutative. That is, for two matrices, A times B is not equal to B times A. There are exceptions, which is if you multiply a matrix A by its inverse, and multiply it in reverse order, you'll still get the identity. But that's an exception, not a general rule. Yeah? Alright, cool. But what we're here for is to see how to actually multiply two matrices. Wow, this important rule is obviously important. Yeah? So for that, let's look at this. So suppose we have this matrix A here and this matrix B here. So our first question is, can we multiply them? And the answer is yes, because this here is a 2 by 3 and this is a 3 by 2. I said a 2 by 3, this here, and this is a 3 by 2. And in fact, we even know our result is going to be a 2 by 2, right? And again, this is a 2 by 3 because it's got a first row, second row, and then 1, 2, 3 columns. And this is a 3 by 2 because it's got first row, second row, third row, and then first column, second column. So it's got 3 rows and 2 columns, and therefore a 3 by 2, and this is a 2 by 3. You get it, you get it. All right, so how do we multiply these two matrices? So it works out pretty interestingly. First, as we said, we know that we're going to get a 2 by 2, so I've designated 4 spots for where the entries of this 2 by 2 will go. These are just placeholders, obviously, not the result of the product of these two, right? But yeah, first let's look at what will go here. What will go here is you take the first row of A and make it vertical next to the first column of B. So that'll look as follows. So first row of A made vertical next to the first column of B. Of course, we got to do more, but bear with me on that. I'll tell you what to do, but let's first continue in this manner. So here, for this entry here, it will again start with the first row of A made vertical, but this time next to the second column of B. So first row of A made vertical, this time next to the second column of B. Yeah? Okay, cool. And so now you must be thinking we gotta involve the second row of A, and that's exactly right. So next for this spot, we'll take this second row of A and make it vertical for that spot next to the first column of B. And then for the final spot, very predictably, we take the second row of A and make it vertical, this time next to the second column of B. Okay, so we're here. What do we do next? Simple. You multiply these two, you multiply these two, and you multiply these two, and add them together to form this first entry. And keep in mind that any one of these numbers may be negative, but that's what you do. You multiply these two, and these two, and add together, and that'll be this first entry here. And similarly for this guy, multiply these two, add them together. So if you do all that correctly, this is what you'll have. You'll have this 2 by 2.